Example 1, finding critical values for the chi-square distribution. We want to be able to find the critical values that separate the middle 90% of the chi-square distribution from the 5% area in each tail, assuming 15 degrees of freedom. Now, we would want to perform the following steps to obtain the critical values. Step 1, we draw a chi-square distribution with the critical values in areas labeled. Step number 2, then we're going to use the table to find the critical values. Now, first things first, it says here that in step number 1, you can see in figure 19, it's going to show us that the chi-square distribution with 15 degrees of freedom and the unknown critical values labeled. Now, before we get into the next couple sentences, let's go back up here. It's saying that we want to find the critical values that separate the middle 90%. Okay, so over here in the first 4 steps, I'm clearing this up here so that you can see that alpha is going to represent 1 minus that 90%, which is 0.90, which gives us 0.10. So in step number 1, we can see that alpha is going to represent 0.10. Now, if we follow the alpha divided by 2, which is going to equal 0.10 divided by 2, it's then going to give us 0.05. So now alpha divided by 2 is equal to 0.05. Now, in step number 3, if we want to find this chi-square of 1 minus alpha divided by 2, it's the same thing as chi-square of 1 minus 0.05, which becomes chi-square of 0.95. And then in number 4, we just have the other critical value, which is chi-square of alpha divided by 2, and we know that alpha divided by 2 is 0.05 from step 2. So here are our 2 critical values, chi-square of 0.95 and chi-square of 0.05. Now coming back to this paragraph, the area to the right of the critical value is 0.05. So here is where we're getting the area of 0.05. Okay, so we denote this critical value here on the right, which is what we got in step number 4, as chi-square of 0.05. So that's given us all the critical value or the area to the right because that's what the table gives us. Now, if we look to the left of this entire piece, in the middle, we have an area of 0.90, and then if we add this area, it's 0.05. So what that ends up is, if we add those 2 together, that's going to give us now an area of 0.95. So what they're saying here is that the area to the right of the left critical value, so this entire area here, is taking 1 and subtracting the 0.05, which gives us 0.95. So we're going to denote this critical value of chi-square of 0.95. So therefore, we can see here that in step number 3, that's what we got for that particular critical value. So in order to find this critical value, we have to use an area of 0.95. In order to find this critical value, we need to use the area of 0.05. And then we have to also use the degrees of freedom that was given to us in the question. So we're going to use 15 degrees of freedom. So now in figure 2, what this is going to show is a partial representation of the table of critical values of the chi-square distribution. Now the row containing 15 degrees of freedom you can see here is boxed. The columns corresponding to an area to the right of 0.95 is boxed in addition to the area of 0.05. So where we see 15 and 0.95, that gives us a number of 7.261. And that's going to represent the chi-square with an area of 0.95, which is 7.261, which is the one on the left. This number needs to be smaller than the one on the right, which you'll find out it is. We have the column of 0.05 using the degrees of freedom of 15 gives us a value of 24.996, and therefore there is the critical value on the right here. So as you see, as we increase going to the right, these numbers need to increase. So there's the critical value on the left, 7.261, and then the critical value on the right is 24.996. Now, when you're studying the table for the chi-square distribution, you're going to notice that the degrees of freedom are numbered from 1 to 30, inclusive. And then we go from 40 and then to 50 and then to 60 in increments of 10 all the way to 100. Now, if the number of degrees of freedom is not in the table, then you're going to choose the degrees of freedom closest to that desired. If the degrees of freedom are exactly between two values, then you're going to find the mean of the values. So for example, to find the critical value corresponding to 75 degrees of freedom, you're going to compute the mean of the critical values corresponding to 70 and 80 degrees of freedom.